मेरे को आप कॉर्नर में कर देना स्क्रीन के. So hello everyone. So this is our first lecture of our this YouTube live series, and the topic for today's lecture is relating truth table, Minterm, Maxterms, and SOP POS. So before starting, is the connectivity proper? You are able to hear me properly? So some students can respond whether am I clearly audible. So once the confirmation comes, I will start. So I think, am I clearly visible and audible also? Okay. So let's start with the today's contents. So we will be starting with the representation of Boolean expressions. Okay. So when we discuss about these truth tables, so one thing we have to be very clear that truth table is what? That there will be some inputs and there will be some outputs. For what value of the input you are going to get what kind of output, either it will be low output or high output. Okay. So the thing is, the output is having either high terms or low terms. Okay. So if you focus on the high terms, then the expression which can be written from the truth table will be of this SOP type, sum of products. So it will be obtained from the expressions obtained from the high terms. Okay. Similarly, if we focus on the zero entries in the output column of the truth table, in that case we will be using the product of sum form. Okay. So these are represented as, or we can see that simply this is, for example, we have mentioned a expression AB plus AC. So AB is a product, AC is a product. So these are the two products. So these two products are added together. So this becomes the SOP. Okay. Similarly, A plus B into A plus C. So A plus B is a sum. A plus C is another sum. So this is sum, and when these two sums are multiplied together, so this becomes product of sum. These two sums are being multiplied together. Okay. So what are the canonical representations? So if we want to relate, so which is our topic of the lecture as well, if you want to relate truth table and its high and low entries in the output, then these canonical expressions, these canonical representations of SOP and POS are going to be very much useful. Okay. So what are these canonical SOP and canonical POS? So if I say that if I want to check that AB plus AC, the first expression, this one, this expression is canonical or not. So canonical says that if all the products in a SOP expression contain all the variables, that means if A, B, we can check that there are three variables A, B and C. So if this first product would have been containing A, B and C, all three, similarly the second product AC, if it would have been containing all three variables either in direct form or in complemented form. So in that case, if both the products were having all three variables, in that case the expression would be termed as canonical sum of product. Similarly for the POS expression, if all the sums are having all the variables, then it will be termed as canonical POS. Okay. So we can convert the SOPs, normal SOP or a non-canonical SOP into a canonical SOP. Similarly, a non-canonical POS into a canonical POS by following some simple methods. So convert the above mentioned expression into canonical form. So let's take the first expression, AB plus AC. So this Y is equal to AB plus AC. So we can check that in this first product C is missing. So as these are products, so I have to take care, I have to multiply it with something which does not affect the product. So I am multiplying it with 1. Similarly, this AC is also multiplied by 1. Now I will be replacing this one with the missing variable. So in the first product I can see that C is missing. So I will replace this one by C plus C complement. Similarly, in the second product, AC is there and I will replace this one by B plus B complement. Okay. Then I will simply multiply that. It will become ABC plus ABC complement. Similarly, proceeding to the second product, which is have to be made canonical. So this becomes ACB. So ultimately it will be, if I write in sequence, then it will be ABC and ACB bar. So it will be A, B bar and C. Okay. So from this now I can check that these two terms are getting repeated. So we also know that from the Boolean law that A plus A is equal to A only. Okay. So from that point of view, these terms which are getting repeated, I have to omit those terms which are getting repeated. So ABC plus ABC complement plus this last term A B complement C. So this becomes the canonical SOP for this first expression AB plus AC. Okay. Similarly, proceeding towards the next form, this is provided to in form of a non-canonical POS. So if you want to convert this non-canonical POS into a canonical POS, so I have also received the comments. Yes, Vijendra has said it's not canonical. Yes, it's not canonical. And now proceeding towards the POS. In POS, we have to make such arrangements that the sum is unaffected. So this A plus B, C is not there, so I am adding 0 into this sum. Similarly, A plus C plus 0. Okay. Now I have to replace this 0 in terms of missing variable. Okay. So A plus B plus 0 can be written as C dot C complement. Similarly, this A plus C, B is missing here, so it will be B dot B complement. Okay. So now applying distributive law, considering this as X, this as Y and this as Z. Similarly, this thing as X, this as Y and this as Z. So I will be using X plus YZ is equal to X plus Y into X plus Z. Okay. So applying this distributive law, I will be getting A plus B plus C, then A plus B plus C bar. Now coming to the second one, A plus C plus B. So writing it sequentially, I will be writing it as A plus B plus C, and the last one A plus C plus B bar. So I will be writing it as A plus B bar plus C. Now I can check that this A plus B plus C is getting repeated. So I can remove one of these. So the final canonical becomes A plus B plus C into A plus B plus C complement, and the last one will be A plus B plus C. Okay. So this becomes the canonical POS for the given non-canonical POS expression. Okay. So this is how we can convert a canonical form into non-canonical form. So if you are having any queries, you can post in the chat box. So I am proceeding towards the next topic, and once the next topic is over, I will be coming back to your queries. Or what we can do is you can mark your queries once the contents are completed for the lecture, then I will be getting back to your taking your queries. So in the meantime, you can send your queries in the chat box. Okay. So we will be taking all these queries one by one. So now we are aware that how we can convert a canonical form into a non-canonical form. Okay. So now relating these canonical and non-canonical forms or with the truth table. Okay. So I cannot relate non-canonical terms, non-canonical versions of the expressions with the truth table, I can only relate the canonical ones. So I am taking a two variable truth table in which there are two inputs A and B. These two are the inputs. There is a single output Y. I have deliberately left it blank. Okay. So we can have any value here, but before putting the output values either in form of 0 or 1 in this Y column, I just want to show you that how a truth table can be converted into a canonical expression. Okay. So for canonical expressions, if you want to write in SOP form, then you have to refer this Minterm. Okay. Similarly, for POS, you have to refer Maxterms. That's why for Minterm this M is smaller, and for Maxterm this M is capital. Okay. So this is how these Minterms and Maxterms are to be written. So first, taking the first row, inputs are A is equal to 0, B is equal to 0. So if you write an expression for this, then it will be written as A bar B bar, because both are 0. Okay. Similarly for the second row, A bar B, because A is 0 and B is 1. Last one, sorry, third one, A is 1, B is 0, A B bar. Last row, A is 1, B is 1, so A B. Okay. Similarly for the Maxterm. So if we check the Maxterm, Maxterm is related to product of sum. That means all these rows will be generating sums. In case of Minterms, all these rows have generated products. So if we check the product, so both are 0. You have to remember that we have to simply reverse the things which we have used for writing Minterms. That means 0 was represented by bar and 1 was represented by non-bar. But for Maxterm, we will be using non-bar terms for zeros. That means 0 is there, 0 0. That means A plus B. Then 0 1, that means A plus B bar. For 1, I am using the complemented form. Similarly, for the third row, it will be A bar plus B, and the last one, 1 1, it will be A complement plus B complement. So these are the canonical expressions which can be generated from these rows of the truth table, either in SOP form or POS form. And the thing is, we have not yet covered the output of this truth table. We have not mentioned what is the output of this truth table. So if we check the output of this truth table, so we can place random entries. So if I write, let's suppose if I write 0 1 0 1 in this output column. Now how this truth table is going to translate into an expression, canonical expression for SOP and POS. Now we can check that Minterms is product. That means I will be multiplying this expression with the product. So A bar B bar into output 0. So I am writing the canonical SOP. Okay. So canonical SOP, A bar B bar into 0. Next row, A bar B into 1. Third row, A B bar into 1. Fourth row, A B. Third row is A B bar into 0, and the last row, A B into 1. Okay. So this thing is 0. This thing is also 0. The remaining term is A bar B bar, sorry, A bar B A bar B, and the last one from here plus AB. So this is the canonical version of this truth table, canonical expression which has been written for this truth table. Okay. Similarly, we can write the expression for this Maxterm. Okay. Or we can simply see that we will not be using this method for all these things, but we can see that wherever the output is 1 in the truth table, only those terms are getting are appearing in the canonical expression. So there are two ones for the first row and the fourth row from which the expressions are mentioned here. Okay, and similarly, if we want to write the min terms in terms of a number, if we want to write these things, we can see that this a bar b thing is 0 1. 0 1 is equivalent to 1 in decimal, and similarly this one corresponds to 1 1, which is equivalent to this 3 in decimal. So min terms y is equal to summation m, these min terms are 1 and 3. So this becomes the min term expression of this canonical version. Okay, similarly we can proceed for this max term. So max term is this one. Okay, we have seen that for canonical SOP, for writing canonical SOP, okay, for writing canonical SOP, we have used the high values in the truth table, and similarly for writing canonical max terms, canonical POS, we will be using the 0 values. Okay, so if we use the 0 values, that means this one and this one. Okay, first and the third row. So we can see that a plus b, in that case it will be a plus b into this third row, it is 1 0, that means a bar plus b. Okay, so this is the canonical POS expression for this truth table. Okay, and similarly if we check the values, this 0 is available at this 0 0 input which corresponds to 0, and similarly this 0 is available at 1 0 input which corresponds to 2. So this 0 and 2, these becomes the max term numbers. Okay, so in this way we can write truth table. From truth table we can write SOP, POS, Minterm and Maxterm. So if there is any query, I am checking the chat box. There is no query yet. So let's proceed towards the next topic. Next topic or not, we can say that we are just having the 3 variable truth table. So now there are 3 variable truth table. So in this 3 variable truth table, let's feed the values first. Okay, so can anybody write the 8-bit binary number in the output? Any student who can write 8-bit binary number in the output? Okay, so once you write this 8-bit binary number in the output, I will be using that 8-bit binary number I will feed that 8-bit binary number in the output column. So I am just waiting for some of the students reply in the chat box. Just write 8 bits in binary which I will be using for the output, and for that output I will be generating the Minterms and Maxterms. So any student who can write 8-bit binary number in the chat box? So if there is no reply from your side, in few seconds I will be writing the number on my own. So Vidhi has mentioned an 8-bit number. I am writing that number as 1011. Okay, so 1011 and 0100. 0100. Thank you Vidhi for the reply. So this is, now this truth table is complete. There are 3 inputs A, B, C, and there is one output Y. Okay, this is my output and this is the input. Okay, so I prepared the truth table. From input side I am having values 0000 to 111. So one thing is very much clear, that from this truth table itself I can simply write the SOP and POS. Okay, so these expressions can be simply written from the truth table itself without going into their canonical SOP or canonical POS form. Similarly, this max term, the terms which are giving you low output, these can also be written directly from the truth table. So I will be waiting for your reply in the chat box. Till the time I am converting these terms into Minterm and Maxterm, that means canonical expression. So I will be waiting for your reply in the chat box for number of Minterms and number of Maxterms here. The numbers which are giving you the output locations which are giving you high and low output. So for the time being, if I am using if I want to add the canonical SOP, okay. So we have seen that for canonical SOP I will be using only these terms which are giving me the high output. So these are the 4 locations which are giving me the high output. So I can see that for this 0 0 0, that means A bar, B bar, C bar, M1 will be, sorry, M1 is not going to be used because it is giving us low output. I am not using it. This M2 will be A bar, B, C bar. For this third, A bar, B, C, and this M5 will be A, B bar, C. Okay. So if I add up these 4, then I can write it as Y is equal to A bar, B bar, C bar plus A bar, B, C complement. Third one, A bar, B, C, and the last one is A, B complement, C. Okay, so this is canonical SOP. Now I am going to write canonical POS. So once I write this canonical POS, then I will be checking the chat box for your replies. So I am waiting for your replies. I am expecting these 2 Minterms and Maxterm expressions from your side. Okay. So these Minterm and Maxterm expressions, I am expecting these answers from your side in the chat box. You have to write the terms which are giving you the Minterm and the terms which are being used as Maxterms. Okay. So canonical POS, for that canonical POS I have to use the outputs which are giving me these 0 outputs. So there are 4 locations. Okay. So this first one, it will be A plus B plus C complement. For this one, it will be A bar plus B plus C. For this one, A bar plus B bar plus C. For this one, A bar plus B bar plus C plus C bar, because all 3 are 1. Okay. So this Y for canonical POS will be this thing, A plus B plus C complement dot A bar plus B plus C. Third expression, A bar plus B bar plus C, and the last one, A bar plus B bar plus C bar. So these are the canonical expressions for SOP and POS which are being obtained from this truth table. So now I was expecting the replies in the chat box. Vijendra has replied for Maxterms. So Maxterms we can simply check where the output is 0. That means this corresponds to 1, this corresponds to 4, this corresponds to 6, and this corresponds to 7. So Vijendra has replied 1, 4, 6, 7, which is absolutely correct. So this 1, 4, 6 and 7 are the Maxterms. Similarly, Minterms can also be written from this truth table only. Okay. So Minterms are the locations where output is high. So high output means that these locations, this one 0, 2, 3 and 5. So this 0, 2, 3 and 5. Okay. So these are the locations which are giving us high output. So these are the Minterms. Okay. So I am leaving a question for you. Question is, Minterms, listen carefully, Minterms are the locations in the truth table where output is high, but they are called Minterms. High is mentioned as min. Okay. and max terms are the locations in the truth table where output is low. Okay, that means low means, and low is being represented as max terms. So it seems to be a bit confusing that high terms are referred as min and low terms are referred as max. Okay, so can you answer this in chat box? Why is it so? Okay, if you feel that the answer is not known to you, simply write in the chat box that you need the answer for that. Then I will be taking that answer, giving that answer at the end of the session. Okay, so let's proceed further. Obtaining truth table from expressions. So in the previous case I was having the truth table. Okay, I was having the truth table. Now I am having the expression, and for that expression I want to write the truth table, Minterm, Maxterm and all these things. Okay, so this AB bar plus C, this is the expression. So Y is equal to AB bar plus C. And for this I have to prepare the truth table, I have to find the minterms, I have to find the maxterms, I have to write the canonical SOP. So in the previous topic or the previous slide we have seen that truth table was giving us canonical terms. So to prepare the truth table I need the canonical expression. So but this expression is not canonical. So first thing will be to convert this into a canonical expression. For that I will be multiplying this AB bar with C plus C bar and this C into A plus A bar into B plus B bar. Okay, so let's multiply it. So it becomes A B bar C plus A B bar C bar plus expression from this side, this C into A, this becomes AC, the C into A bar, that becomes A bar C into B plus B bar. So this thing I am repeating, it is A B bar C, A B bar C plus A bar, sorry, A B bar C bar plus this AC into B, that means ABC, then this AC into B bar, A B bar C, then this A bar C into B, A AC into B bar, it will be A B bar C, and the last term A bar C into B bar, A bar B bar C. Okay, so this is the expression. From this expression I have to check that if some of the terms are getting repeated I have to remove those terms. So I can check that this term and this term is getting repeated. So I am removing the redundant terms which are getting repeated. A B bar C plus A B bar C bar, then A B C, then fourth term, this is also getting repeated, this is also getting repeated, so I am not mentioning it again, and the last term is A bar B bar C. So these three terms were getting repeated, so I have mentioned it only once here. Okay, so this is the canonical expression. Now in this canonical canonical SOP expression, so I am replacing this non-bar term with 1 and bar term with 0. Similarly here 1 0 0 1 1 1 0 0 1. Okay, so now this 1 0 1 is equivalent to 5, 1 0 0 is equivalent to 4, 1 1 1 is equivalent to 7, 0 0 1 is equivalent to 1. Okay, so I can simply write the minterms from this expression, which will be 1 4 5 and 7. Okay, so these are 1, 4, 5 and 7. Need not to say, if these 4 are my minterms, then the remaining ones will be my maxterms. So Vijendra has replied, sir, second last term should be A bar. Second last term should be A bar. Okay, I am checking it. Second last term should be A bar, A into A bar, AC, A bar C, B plus B bar, then AC into B, ABC, AC into B bar, A B bar C, then A bar, yes, A bar, exactly, A bar C in, this is A bar, okay, I am correcting it, A bar, so this is A bar, and again A bar C into B bar, A bar B bar C, so this term is now common with this last one, so A bar C into B, so it becomes A bar B C, so I am correcting it, A bar B C, okay, A bar B C, and the last one will be A bar B bar C, okay. So now this term is not getting repeated anywhere, A bar B C, so this will also be producing, okay, so this will A bar B C, this will also be producing a minterm which can be written as 0 1 1, which will be equivalent to 3, that means 1 3 4 5 7. So there are 5 minterms, so this is equivalent to 0 1 2 3 4 5 6 and 7. So 1 3 4 5 7, these are the locations which are having high output, 1 3 4 5 7, and the remaining ones are the locations where I will be receiving 0 output, okay. So maxterms can be referred as 0 2 and 6, 0 2 and 6. So systematically writing it as y is equal to summation m, it is 1 3 4 5 and 7, and for maxterms it will be pi capital M 0 2 and 6, okay. And canonical SOP, this expression in algebraic form is the canonical SOP expression, okay. So बिल्कुल सही, विजेंद्र की तरफ से continuously applies हैं हमारे पास 1 3 4 5 7, so 1 3 4 5 7 and 0 2 6, these are the minterms and the maxterm expressions. So this is how we can write a table from the expression, and how from an expression we can write a table. So this thing we will be using again and again in the complete subject. So it is very much important to have knowledge of this thing, because the complete subject is full of truth tables, full of expressions, full of minterms, maxterms. So once this concept is known to you, you can very easily write these expressions, minterms or maxterm for the other truth tables as well, okay. So now I am open to the queries. So if anybody has any query, you can write in the chat box, and I am also expecting the answer for that question I had asked. Why minterm is called minterm? Because minterms are the locations which give high output, but it is being referred as minterm. And why maxterm is referred as maxterm, despite of the fact that it is giving you the low output, okay. So if you feel that you know the answer to that, you can attempt it in the chat box, or if you are having any query regarding this same thing, you want me to write any truth table for a given expression, or for a given set of truth table you want me to write the expression, you can type in the chat box. And if you don't know that answer to that minterm maxterm question, you can also type in the chat box that you are not knowing the answer and you need the explanation for that, okay. So no reply is coming from the students. So I am answering that question. Okay. So let's, why Minterm is called Minterm. So Minterm is related to SOP. SOP is having multiple products. Okay. So if there is a product, let's suppose there is this thing A bar B C. So this product, any of these products, I am taking one of these products. If in this product there are three members which are being multiplied. Okay. There are three members which are being multiplied. For these three members, if any of these three members becomes minimum, if any of these three members is minimum, then this whole product will be minimum. Although it is written for that entry in the truth table which is giving you high output, but the expression is such that in this product, if any of the component which is participating as a variable in this product, if that becomes 0, then the complete product becomes 0. That's why for this SOP we are using it as Minterms, because these variables have the capability to make this complete product as a minimum product. Similarly, if there is a POS, POS is having multiple sums, product of sums. Okay. So these multiple sums, I am answering, why is Maxterm called Maxterm? Despite of the fact that Maxterm is the location which is giving you 0 output, but why Maxterm is called Maxterm? Because Maxterm is related to POS. POS is having multiple sums. Let's take one of the sums. Let's suppose the sum is A bar plus B bar plus C. This is one of the sum. Now if you check that there are three members which are being summed together, if any of these is maximum, either A bar is maximum or B bar is maximum or C is maximum. Okay. If any three of these is maximum, then the complete sum is maximum. Okay. Now again I am linking all these things. Maxterms are the locations which are giving you 0 output. So even if it is 0, the expression is such that the variables in the expressions, if any of the variable in the expression is having a maximum value, maximum means high value, if any of these values is maximum, then the complete expression becomes maximum. Okay. So that's the reason why Maxterm is referred as, the locations which are giving you 0 are referred as Maxterm, because any of these variables, either A bar or B bar or C, have the potential to make this complete expression into high expression. Okay. So that's why these are being referred as Maxterms. So this is all from my side regarding this truth table, Minterm, Maxterm, canonical SOP, canonical POS. So if there is any further query from your side, you can type in the chat box. I am waiting for your questions in the chat box. If there is any query, you can write the queries, or if it is clear to you, then you can simply give a thumbs up or all clear, okay, whatever, an indication that today's lecture is successful, so that we can plan the next lecture accordingly. So Vijendra is the only, I think, student who is actively participating. So we are concluding now. So now there are some replies. You can also send in the chat box next topic is going to be Carnot map, K-map, which is again a topic which is going to be used multiple times in our subject. So now I am expecting answers. Now I am expecting that what all topics from unit 2 you need to be converted into this live lecture. You can also send it in the chat box. I will, the topics for which I am getting the maximum replies, I will be covering that topic from unit 2 in this live lecture series. Okay. So if there are no queries further, we can end today's lecture. Thank you very much.